Hello friends, welcome to my channel. In this video I will cover mechanics, properties of plane sections, area centered and area moment of inertia, section modulus and radius of gyration I will tell. Here in this circle area is pi r square, in diameter term pi by 4 d square x bar this distance. This is x bar parallel to x axis and y bar is parallel to y axis. It's d by 2 in d term, here d by 2. Then I11 and I22 moment of inertia, its value is pi by 4 r square or pi by 64 d to the power 4. Then polar moment of inertia J, I1 plus I2, you will get pi by 32 d to the power 4, or in r term you will get pi by 4 r square into 2, you will get pi by 2, this should be r to the power 4 here, pi by 2 r to the power 4. Then section modulus. Section modulus Z1 equal to Z2 I by Y maximum. So you will get it's d by 2 pi by 32 dq. Then here radius of gyration square k1 square and k2 square r square by 4. I already told I equal to a k square, so k square equal to I by a. Put the formula, you will get this result. Then for annulus region, outer radius is r2 and inner radius is r1. Area is pi r2 square minus r1 square. X bar and y bar both are r2. Moment of inertia I11 equal to I22 equal to pi by 4 r2 to the power 4 minus r1 to the power 4, or in d term pi by 64 d2 to the power 4 minus d1 to the power 4. This is very important for GATE and IES. They will ask questions, problems based on this formula. For strength of material also, for hollow shaft you have to use this formula. So this is very important. Then for semicircle having radius equal to r, area is pi by 2 r square, x bar this distance, x bar. Then y bar is very important, so many times asked in PSU examinations. Also important for other IES and GATE also, this is very important. Y bar is 4r by 3 pi, x bar is r. Whenever they won't give you calculator, so you remember this formula also. 0.42 r, y bar value is 0.42 r or 4r by 3 pi. Then I22, I11 they won't ask you, I22 you just remember pi by 8 r to the power 4, k2 square also not that much important. Radius of gyration square equal to, this is r, radius square by 4. For ellipse, area is pi into a into b, then x bar this distance from here to here, x bar is a and y bar is b, I11 moment of inertia along 1 axis pi by 4 ABQ and I22 moment of inertia along 2 axis pi by 4 AQB. Then section modulus Z1 equal to pi by 4 AB square Z2 section modulus 2 pi by 4 A square B. Then radius of gyration square K1 square is equal to B square by 4 and K2 square equal to A square by 4. For ellipse, these 5 things are important. They may, other than this, sometimes they may ask, but these 5 are important. Then for parabola, area A equal to 4 by 3 AB, x bar equal to 3 by 4 A and y bar equal to 0, Ixx, this is very important. Ixx equal to 4 by 15 ABQ. For rectangular section having base B and height h, moment of inertia along this axis, let it be C. IC is BHQ by 12. Here also for hollow rectangular section, this is very important. So many times asked a lot of examination. Even if gate also, this is very important. I equal to h to the power 4 minus small h to the power 4 divided by 12. Then properties of solid bodies. Mass moment of inertia we will calculate here. For thin rod, this one so many times asked in gate examination. So this is very important. Having length L, volume V equal to A into L, x bar is L by 2, y bar equal to 0 and z bar equal to 0. Then Ix, mass moment of inertia equal to along xx is equal to 0 and mass moment of inertia Iy equal to Iz equal to ml square by 3. Then I2 along 2 axis and along 3 axis mass moment of inertia is ml square by 12. Just apply parallel axis theorem and you will get your answer. Then radius of gyration kx equal to 0, radius of gyration ky equal to kz equal to L by root 3. This is also very important. And k2 equal to k3 equal to L by root 12. Then for thin circular rod having radius r, volume is 2 pi r a and x bar, y bar and z bar, these are the centroid distance. X bar is r, y bar equal to r, z bar equal to 0. I1 equal to I2. This is useful for flywheel problems. I2 and I1 equal to mr square by 2. I3 is mr square and radius of gyration K1 equal to K2 equal to r by root 2. These are very useful in mechanics. All these formulas, strength of material and also theory of machine. All these formulas are useful for all examination, PSU, IES, engineering mechanics they won't ask, but strength of material and theory of machine, these formulas are useful. And sometimes in design of machine elements also, you have to require this formula. So thank you friends, thank you for watching my video, thank you.